right. So, testing in Android. Very exciting. As already introduced, my name is Brett. I'm an Android dev here at Victorious. And I'm going to talk about 3 frameworks that maybe will help you write unit tests for your Android project. One is Mockito. I'm going to follow up with an extension of that called PowerMarketo, which is really sort of PowerMock under the surface there, and Robolectric. And but before I get into that, has anybody maybe seen something like this before in your project, by any chance?
Has someone written something like that?
Yeah. Well, you probably haven't written it because it's auto-generated for you when you build a new project in Android Studio. And I just wanted to point this out because it's anecdotal evidence, I suppose, but a lot of GitHub repos I've looked at of other developers, they have just this in their test directory. So some people maybe not writing so many tests. Also, some other people I've talked about, they kind of give me this feedback that, oh, well, you know, I just gotta like slam through this project. I don't have time to write tests. The manager doesn't give me time to write tests. There's no time. So, man, I don't have time to write tests. So why should we write tests? Well, a couple things. One, it helps promote a stable product. You have sort of a contract on how your code works, and basically, if your tests pass, well, you know, you have at least some sort of guarantees that, you know, hopefully things are actually kind of working. And if something breaks, you figured out that, hey, there's something you should go back and fix because, you know, pretty self-explanatory. Promotes cleaner code if you're using something like test-driven development or just trying to write any test whatsoever. You'll probably find that your spaghetti code is more bug-prone. And if you're writing tests, you're probably going to find that you can't write tests for your spaghetti code, so you're going to start trying to like clean it up, write better code that's easier to read and understand. Also, there's 2 ways you can write tests on Android. You can write instrumentation tests, and these are tests that run on a device, and you can do like UI tests. You can still write unit tests on a device, but you can also run your unit tests on your local machine. And here's an example that Keanu Reeves is really excited about. About 400 tests here running in under a minute for a project. Now, these all run locally, and if we were trying to run all this stuff on a device and you're trying to iterate through some sort of TDD style, you know, run your tests, you know, change your code, make the test pass, etc., and you're like just using instrumentation tests, you're building the project, you're reinstalling it on a device, it's super slow, nobody wants to do that. If you can just blow through hundreds of tests, you can easily write your code and test that all the tests pass for all of your unit tests. And of course, there's certainly a place for UI tests, so not to, you know, look down on you. But definitely, if you want to write tests for your business logic in your project, you can totally do that in Android, and it's super fast. And of course, if it's super fast, people are more likely to run them because you don't have to go through all this hassle of using a device to run them. So,
to me, if you write the test near the beginning, the largest value of that is to get an agreement with people that this is what it's supposed to do when I'm done.
Certainly, definitely.
Yeah, so that I mean I've done that where we wrote tests at the beginning.
Right.
After about a 4-month project, we got it all done and integrated everything together, and it took about an hour and a half.
Definitely. So, if you're writing tests in Android, there's a couple of frameworks that can help speed things along. One of them, maybe it's kind of like a launching point for some of these other frameworks, is Mockito. And Mockito is a mocking framework, and I just want to go over a couple of key terms so that we're all kind of on the same page. So Mockito claims it's a mocking framework, so of course you're going to be dealing with mocks, mock objects. What is a mock? Well, a mock is kind of like a stunt double or maybe like a crash test dummy, so to speak. You're running your test and you don't want to use the real deal. You're going to have somebody stand in and interact with your code that's under test. And like let's say for example you have some sort of like database layer or something crazy. You don't want to have to build all that stuff or go through some hassle on creating elaborate code. You can use Mockito to help quickly mock maybe some interface or something that you're interested in, not the real deal. So what you're testing something that you're interested in, let's call that the object under test. And anything that's interacting with your object under test, some mocks, maybe some pojos, other objects, what have you, let's call them collaborators. So I'll probably be using these a little bit throughout the presentation, but just so we're sort of on the same page here. So how do you mock things with Mockito? Well, of course, you already have this framework integrated in your project with Gradle or however you want to go about doing it. And in your test case, super straightforward. Instead of instantiating some new class, you're just going to call mock on the Mockito framework and specify what class is supposed to be mocking. And now you're up and running. You don't have to write any sort of elaborate subclass and all these things. Right off the bat, you've got your mock object. What a mock object does is a couple of interesting things that are very useful for evaluating your test case. And by default, since this is a sort of like a fake representation, a test double, stand-in, whatever you want to call it, it just provides a default response for interactions that the real object would really have. So if some method on that class returns a Boolean, it's just going to return false. If it's some other object, it's just going to probably give you null. It also records interactions with this mock object, which is awesome for behavior verification later on. So if your object under test actually interacts with this mock in some way, it's keeping a record of that for the lifetime of the test case. You can mock your real objects. If you just have an interface, you can mock interfaces too. That's real helpful if you're using something like dependency inversion to pass in on your dependencies. And if you just have an interface, you can just run with the mock on that. You don't have to worry about having concrete implementations. So there's something else in Mockito that is useful, but kind of want to caution you on this because you can get into some sort of indeterminate behaviors and maybe you run into things that you're not expecting. It's called a spy. And essentially what a spy does is sort of like a high level, it's a wrapper for a real object. So let's say in your test case you have a cat. You've created a cat, real cat here. And you want to spy on this cat. What are you doing with the spy? Basically, you're augmenting it with similar functionality that the mock object has. And the key difference here is that once you've created your spy of the real cat, anytime you call any methods on your spy object, the mock, as I mentioned before, is just going to have like a default response. It's going to return false or null or what have you. The spy is actually going to call through to the real method. And typically, this is kind of described as like a partial mock. You're actually executing real code, and maybe you're stubbing some parts of it later. That I'll explain what stubbing is. But typically, you want to start with a mock. Maybe as you get more familiar with the framework, you'll see use cases where using a spy is more appropriate. But I just wanted to throw that out there that you can kind of tackle things from an opposite angle, where maybe I only need to deal with some of the support Mockito offers for mock objects on a limited scale rather than mocking the entire object. And so I mentioned stubbing. What is stubbing? What Mockito considers stubbing is having you basically describe a canned response for your test case. So let's say your object under test is interacting with some collaborator, and when that interaction happens, you're expecting that Boolean method to return true. Like I said, the mock always returns false by default. So you can use stubbing to basically say that, hey, when this method is called, every single time that method is called, you're going to return true. That's your stubbed response, canned response, essentially. So instead of expecting some sort of complex logic to happen from a collaborator, basically you can use stubbing to say that, hey, if I'm expecting a certain response from a collaborator, I'm just going to describe how that is within the scope of my test case. I don't have to worry about setting up anything elaborate or complicated. So in this example here, the syntax is pretty straightforward. There's a when method. So you're saying, it almost reads like plain English. When our mock cat speaks, then return meow as a string. Not super complicated. We're just returning, let's say the speak method returns a string. We're just going to say whenever this method is called in our test case, our mock object is going to return meow now instead of, I guess, null or an empty string. There's an alternate syntax you could use. There's a do return, and this is kind of useful for spies. Just wanted to point this out that since we are calling through to the real method in the spy object, they have a separate set of methods in the API that you would use to make sure that the stub works properly with the spy. So let's say whenever we call through on our spy cat that we had from the last example and we want to return meow, okay, maybe that's fine. But maybe if there's some other behavior you want executed and you want a canned response and not executing the real code, you would use the do return option to stub that out. And I just want to point out that be careful about spies and stubbing. Like I was saying, because it calls through to the real code, you can actually be executing code that maybe you're not interested in and getting unexpected responses. So within the scope of stubbing, there's support for matchers, and I think this is originally supported by Hamcrest, but not super important. But if anybody's used that framework, it's basically the same functionality. The idea here is that maybe our mock object, we want to stub a canned response, but maybe we don't actually know the specific value being passed as a parameter to that method. So now we can say, hey, when our object under test interacts with our mock object, we can just say invoke this stub when any integer is passed as the parameter, because maybe we actually don't technically know. Maybe it's like you generate some random value somehow during test execution, and you always want this same default response of returning 1 in this example. You can also use, there's matchers that pretty much cover all the primitives. You can also specify specific classes. It's pretty extensive, and I know Lee here is going to talk about matchers a little bit as well. But the basic idea is that it broadens the scope of the invocation requirements for your stub. And if maybe you also have some collaborators in your test that you don't care about, and you want to have a default response, maybe just return an empty string or something, you can always make sure that for any sort of interaction, that case is covered, and you don't have to worry about running into some sort of unexpected behavior. So I mentioned verifications earlier, and so let's say you set up your preconditions for your test. You have your stubs defined, canned interactions, all your other collaborators are set up, and you execute the code that you're interested in for your test, and then you're going to see what's the aftermath of our test case, right? Did it pass? Did it fail? And you can run assertions on some sort of state, some sort of return value or something like that. But Mockito also offers this way to basically run assertions on behaviors. And they do this they call it verifications. And so what you'll end up doing is, if you have a mock object that has some sort of interaction with it, I mentioned how mocks record all those interactions, right? So at the end of your test case, you can define a verification statement that basically says, did this behavior actually, did this interaction actually happen? Did our object under test actually call the get value method at least once on our mock data object? And it's pretty cool for evaluating behaviors. So there's this idea of like behavior-driven development. I'm not going to get into details on that, but it's an interesting way to test your code beyond just assertions. So a couple tips on tests, definitely not exhaustive, just some stuff that I've stumbled into, some of my teammates have stumbled into in our struggles for writing tests for our project. But be careful about mocking everything. The idea here is that maybe you just have some primitive data types that are being used in your tests. You don't need to write a mock for an integer or even like a simple list. You also don't necessarily need to mock the entire world, because you maybe are artificially creating a scenario that could create a false positive. Like I said before, defer to mocks typically, but as you experiment with the Mockito framework, maybe you can start seeing when spies might be useful for that partial mocking functionality. If you find yourself writing unit tests and you're trying to go back and write some hack to your code to just to make a test pass, might be code smell, and there's a variety of different scenarios for that, but something to just be cognizant of. Another thing about matchers. I mentioned that it broadens the scope that stubs can be invoked, right? But maybe your object under test is passing the wrong values to that method, and now your stub is being invoked, but maybe it shouldn't be. So if you are maybe covering scenarios with matchers incorrectly, you could also result in false positives during your test execution. Asynchronous code, well, there's a lot of callbacks going on in Android and Java code in general. Trying to write tests with asynchronous code can result in, I don't know, trying to write some weird thread, wait, sleep stuff. It gets real nasty. There's a way that you can use the do return, do answer methods within the Mockito framework to basically set up a stub that the idea here is, let's say you pass some callback to a collaborator. Your stub's going to be invoked and immediately call that callback synchronously, because maybe you don't care about what goes on asynchronously in some collaborator. You just want to make sure that your object under test does what it needs to do in calling the mock, and it also follows up when the callback is called with on success or whatever your scenario is. There's ways to do this. I find this code to be a little ugly, but probably cleaner than the alternative of trying to handle all that thread management stuff yourself. So there's some limitations to Mockito, which is why I'm going to talk about a couple other frameworks. Can't mock anything declared static or final, and I guess going back to don't mock everything, you even can't mock primitives. I think you have to do some boxing if you want to use primitives, but not recommended. So PowerMarketo. What does PowerMarketo do? It's basically an extension of the Mockito API. A lot of this stuff is designed to be very similar to Mockito, but basically what it does is it helps you deal with this problem of statics. Maybe you have some helper class with a bunch of static utility methods or something, and it's involved in your test, but you don't actually care about that stuff. You just want to mock it or have your stub set up and get going. Well, PowerMarketo can help you out with that. It can help you out with mocking, stubbing, and verification that interactions with static methods in the classes happen. So, small example here of some more cats. How do you use PowerMarketo? It's very similar, like I said, to Mockito. There's a couple things you have to do. There's some class loader stuff that happens. So when you write your test class, you have to use the prepare for test annotation to identify what classes are going to have any sort of mocking of static methods happen. And this happens at the class level. I think you might be able to do it at the method level potentially. I may be mistaken. And also within your test case, if or maybe your setup method or before method, if you're going to be mocking static methods, you're also going to do something similar to Mockito, where you say hey, mock this class, and now your class is completely ready to have any sort of static interactions mocked and stubbed. And so right below this in the next line is stubbing the speak method, and whenever this method is called, we're just going to get the canned response. Very similar to Mockito. You can basically do a lot of the same things. There's just the extra bytecode wizardry or class loading stuff that goes on that requires you to do some extra identification of static classes that are going to be used. You can do verifications that static methods are called, but the syntax is a little weird. They actually split it up into 2 lines. So on one line, you're basically, it's almost like starting a code block where you're going to say, hey, start looking for verifications of static methods, and along with maybe some matchers of how many times they'll be invoked. And then you're actually just going to say, hey, this method, rather than having it inlined as one method call. Kind of ugly, but that's how it works, unfortunately. So a lot of stuff is for unit tests, but maybe you are doing some stuff in an activity. I mean, this is Android, right? There's fragments. Maybe you're dealing with like some views or something, and things are mixed up, and you're getting I don't know. Maybe you've seen like a method not mocked response from the Android SDK. Robolectric might be an option to help you out with that sort of thing. Basically, what Robolectric does is they have something that they call shadows, and it's a similar concept to like mock objects that Mockito and PowerMarketo deal with. It also lets you run through states and interact with views and other components of Android within your unit tests, and so you're dealing with Android features that are being tested on your local machine, and you still don't have to run it on an actual device, which means way faster. And you can deal with fragments as well. So what is the shadow class? So you've got your some main activity that extends activity or app compat activity and so on. Basically, what happens here is when you create an activity in your test case that maybe is a collaborator or an object under test, what Robolectric will do for you is basically create what it calls a shadow class, and it essentially says that, hey, anything that's within the Android SDK is going to be replaced with the test double of its design, and basically you'll have some basic behaviors that either you can stub out if you wanted to with Mockito, or continue on with your test, and some basic, like for example, if let's say we want to build an activity, Robolectric, similar to how we were creating mock objects, you'll define, hey, what activity are we going to be building, and you're going to have unfortunately the response is an activity controller object. What is an activity controller do? Well, it's part of the Robolectric framework, and essentially what it does is it helps you push an activity through different lifecycle states. And let's say you want to test that something happens in the create method or start, resume. In this example, I'm blasting through all of them. And at the end, I'm going to go ahead and get the object that has been pushed through these lifecycle states. And at that point, let's say I want to then run some assertions that, hey, what happened was supposed to happen when I went through these lifecycle methods. And again, you're still running this within your unit test. The awesome thing here is that it's all very like fine-tuned control for the person writing the unit test. You don't have to worry about trying to guess like, hey, is my activity actually going through these states? You very clearly define what states it's supposed to go through, and then run your evaluations. You can also just call the methods directly on the activity after you've acquired it from the activity controller. You can go either way while running your tests. Here's a more in-depth example, and unfortunately, text is a little too large. I apologize. But the idea here is we're creating an activity within our test case and acquire it after pushing it through create, and an additional call here that basically simulates your activity finally making it on the screen and or being visible on the screen. And let's say we want to manipulate a text view and a button. We can do these calls within the unit test, which normally would fail because now we have our shadow classes working behind the scenes, providing basic implementation for what Android normally does. And yeah, so let's say we've stepped through the code here. We've found some text view that is part of the layout our activity under test has, and a button. And let's say that now we're gonna execute some button click, and we're gonna make sure that, hey, our activity is, maybe it has some like click listener, and it's gonna set some text, hello world in this example, and we can run an assertion on that now, and that totally works. Also, there's support for doing fragments. Somewhat similar, there's a there's fragment test util or support fragment test util for support compatibility fragments. You can basically do the same thing, and as I mentioned with the activity, you can have Robolectric create this fragment for you, and then run through any assertions. If you need to have some sort of interaction with a specific activity when you create that fragment, you can go ahead and pass that activity to Robolectric, and that way, any sort of interactions an activity has, that a fragment has with a given activity will still function as intended. Some limitations on Robolectric that we discovered. Basically, it has its own custom class loading logic that works behind the scenes. PowerMock also has some similar type of like byte weaving class loader stuff going on. That's way over my head, but it's trying to use both of these libraries together. Unfortunately, you're probably going to run into some problems. People have claimed that they've solved this problem of being able to run a unit test that uses both PowerMock and Robolectric, and I don't quite believe that. But another problem that I've noticed with Robolectric is that the Java docs are pretty bare. Sure, they have like the API for all these classes, but don't expect to see any descriptions on what these methods actually do. Probably going to end up on Stack Overflow trying to figure it out, as other people have been trying to learn the hard way, essentially. If you guys want to take a deeper look at this stuff, Mockito.org. There's some good examples on PowerMarketo usage on this GitHub wiki as well, and Robolectric.org has some of the examples that I kind of went through in this presentation. Also, Martin Fowler wrote a great article that goes over these different concepts: mocks, stubs, test doubles, some good examples, and I have a link for that as well. That's it.
Any questions before we switch to it?
I'll be around afterwards, so if there's typos or